All right, so continuing on in section or chapter 4, section 4.2, we want to look at measuring strength of association with correlation. So we looked at before that we can have some association, and let's figure out how we can measure how well does our line fit our data, for example, right? So we'll be able to find and interpret the correlation coefficient. That's what we call, right? So we're going to look at what's called the R value. Right? So the correlation coefficient is simply a number that measures the strength of a linear relationship. So it's important to understand it's for linear only, right? The symbol that we use is a lowercase italic r, and r is always going to be in between -1 and +1, right? So an R value that's -1 indicates a strong negative linear association, and an R value that's +1 indicates a strong positive association, right? And if the value is exactly -1 or +1, that means a perfect, right? And then also R values close to 0 indicates that we have a weak association. So here are R values of 1 and -1, right? So here we're showing the scatter plot on the left. This has an R value of 1, and the one on the right has an R value of -1, right? So if you have a correlation coefficient of 1 and -1, this indicates a perfect positive and perfect negative association, right? So obviously the +1 means a perfect positive, and the -1 means a perfect negative correlation. So that means that these points lie exactly on a line, right? Every single point will be on the line. Right, so here's some more examples of different R values so you can kind of get a sense for what the R value measures. So you can see here and compare, like here this is weight to height to inches to weight to pounds, right? My R value is 0.72. So you can see kind of what a 0.72 looks like, and then if we look to the one on the right, notice my R value is getting closer to 0, right? It dropped, and the correlation is weaker then, right? So as we get closer to 0, it's weaker. And then down here we have an R value that's pretty close to 0, 0.19. You can see there's really not a linear correlation at the bottom here, right, between GPA and math SAT scores. So it says, notice that as R increases, there is less vertical variation in the data. The trend is stronger, right? So the highest R value here would be this first scatter plot we looked at, and notice that seems to fit more of a linear trend where these are more scattered, right? So here's another example of some other R values that you can look at. So like here is R value equal to 1. That's a perfect positive linear correlation. Where here we have a strong positive linear correlation, so 0.9, and then where we get to be about 0.4, we consider this weak, right? This is a weak positive correlation, right? So then you can keep looking here at D. So R of -1, right? This is a perfect negative correlation. -0.9, we would say it's a strong correlation. But then when we get to be about 0.4 or as we get closer to 0, we consider that a weak correlation, right? So those are some terms that you can use, right? So if you have something that's close to 0.9, we can say strong or very strong, or if it's in between strong and weak, we could call it like maybe moderately positive linear correlation or moderately weak correlation. And then down here we have an R value of 0. So this is where we have no linear correlation, right? It doesn't seem to fit a linear pattern, right? So remember that there could be correlation if like R is 0, but there's no linear correlation, right? Is the key. So then this is just some background. So when we convert the R coefficient, it's a little complicated. So in practice, especially at this level, we're just going to use technology to calculate this for you. Or even if you're, taking a more advanced statistics class, I mean, you might learn to do it by hand just to understand, but in practice, you're going to use technology to do that, right? It's a lot simpler. So here's just a slide, just to kind of give you a taste for what the equation would look like, right? So here is the equation for computing the R value from a sample correlation, right? And then here are just some other facts I noticed, right? R is going to be in between -1 and 1, right? And what those values mean, right? So I just reiterated that. So if we do work with the population coefficient, we use the Greek symbol rho, but we're focusing on sample, right? Sample correlation coefficient. Right? So we're looking at the degree of linear relationship between two variables x and y, right? So here's just to emphasize, so a scatter plot, oops, looks like I have a typo. So I have a typo there, so you can fix that in your slides. So it says a graph in which pairs of points x, y are plotted with x on the, so this would be on the horizontal axis, right, and y on the vertical axis, right? So you could fill that in. So x is on the horizontal and y is on the vertical, right? Just like, you know, when you've been plotting points, you know, like in middle school, high school, so forth. So x we call the independent variable and y we call the dependent variable, right? So for example, your weight depends on your height, right? Not the opposite way around. So the weight would be dependent variable and your height would be independent variable, right? So as I increase my height, you would assume that my weight would also increase, right? So it has a positive trend. Also, if I were able to like decrease my height, right, you would assume that my weight would go down, right? But if you increase or decrease weight, that doesn't necessarily influence your height, right? So that's why we say that weight is dependent on the height, right? So height is the independent variable. And then if you want to create a scatter plot in R, and I'm going to show you how to do this in a moment, but you're going to use this command. So you're going to use the command plot, and this should be a lowercase p, like this, right? So you can do lowercase p plot x comma y, or you can do plot and then you can do y tilde x, right? Just whatever your preference is. So I'm just going to use the x comma y format, right? But remember the p there is lowercase. Right, so here's an example to go through. So it's the table below. So it shows us heights and weights for six women. So we want to compute and interpret the R, the correlation coefficient, right? And I just want to point out here that this is not a very big data set, only 6 women. So it's not likely that we would only have this small of a data set. The reason why a lot of textbooks do like small data sets like this is just for ease of entering like in your calculator, or typing a list in R, just to make it easier to know how to go through the motions, right? But we will do some problems with large data sets, right? Especially like the R assignments that I'll make videos to walk you through how to do those. So we'll get practice with large data sets also, right? But I just want to use this small data set for now, because I'm also going to show you how to do this on the calculator. And when you do this on the calculator, it's very cumbersome to have large data sets unless you're downloading the data from your computer, which I don't expect you to do that. Right? So here I just gave you some steps to follow when you compute the R correlation coefficient using R. So I'm going to walk you through how to do that. And then here are some notes just how to do it on the calculator, right? And then here are just some things some key points about R that we want to make sure we understand. So remember that if we change the order of the variables, it does not change R, right? So if I let one variable like age be my X and weight be my Y, then if I swap those around, so I put weight as my X and age as my Y, that's not going to change R at all, right? And then the next point to take note of is that if we add a constant or multiply it by a positive constant, that also does not affect R, right? And then also R is unitless, right? So R does not have a unit attached to it. So it's not like pounds, inches, so forth. And then lastly, I try to emphasize this throughout, R is only useful to measure linear trends, right? So this is just a note that I put. So we should always graph your data first before you compute R and try to make any conclusions about R, right? So we should always look at a scatter plot first. Look how my data fall. Does it look to be linear? If it does look to be linear, then you proceed, right? If it's very obvious that it's nonlinear, then there's no point in calculating R, right? Because R is only for linear. All right, so let's go into R. All right, so you can just open up R. I'm going to make the text bigger for you. Right? All right, so since we're not pulling in an Excel file, right? Remember, we don't need to set up the working directory, right? That's only if I'm importing some type of file in here. So since my data set's really small, I'm just going to use the C command and type it in like we've done a few times, right? So we have two data. So I'm going to name my height variable. I'm just going to call that variable height, right? So you can do height equals and then do the C command and type it in. So we can do 61, 62. So just pulling this from one of the slides, right? Slide 9, 61, 62, 63, 64, 66, and 68, right? So that's one variable, and then I also need to put in the variable height, right? And I'm just naming these as such, right? So we have 104, 110, 141, 125, 170, 160, right? 104, 110, 141, 125, 170, 160. Good. All right, and one thing to note, though, is that the order that we type in these numbers matters, right? So, like, 61 and 104 go together, right? So ours is assuming that the first two go together, like X, Y, and the second two go together, and so forth, right? So we can't swap that order around, right? So you want to be cautious of that when if you're typing those in, right? So order matters when we're typing those in here. So then the next thing that I would do is do a scatter plot, right? So to do that, we can use the command plot, P-L-O-T, and then we put our X variable first, so height, and then comma weight, right? And if I enter, it'll pop up with a scatter plot, right? So there's my scatter plot. Oops. Yeah, so let me get rid of that. So another thing I want to show you do is how we can add a title, and we can change the color of our data points if you'd like, right? So if I click, I'm just going to click the up arrow, and that's going to, if you click up the up arrow in R, it just pulls what we typed in last, right? It just makes it easier if we want to add some things. So I'm going to type COL equals, and then you have to put this in quotes. This is how we can add a color. So maybe I want to make the data points dark green, right? Then that they'll now be dark green. I can hit comma, and then I can also use the main command to add a title. So you have to do main equals and put this in quotes, and we could put a title, I don't know, height versus weight for women, right? Something to that effect. So now if I hit enter, my scatter plot popped up, and these data points are now dark green, which to me, I can't tell a big difference, but they are definitely different than black, right? And then our title is added, right? So if you want to change any of this, right, if I exit out of the scatter plot, then I could click the up arrow again, and I could change the color, I don't know, maybe yellow, right? That way, just to see if it's working okay, right? And those definitely are yellow, but that's really hard to read, right? So you can play around with that, right? If you'd like, right? Or you can just not add in the COL command at all and just do the height, weight, comma, and then you can do the main to add the title to the graph and just leave the color black. That's perfectly fine also, right? So then we have a scatter plot, right? So let me go back up to my scatter plot, and I'm actually just going to delete the color, right? So delete the color line. So here's my scatter plot, and I mean, we only have 6 data points, but I mean, there very well could be a linear relationship here, but again, we only have 6 data points, so it's really hard to draw conclusions from. So we'll go ahead and proceed with calculating R, right? Because that's what this example is to help illustrate. So to find R, define the R value in R, use the correlation command. So it's just COR, and then you type in your X variable, which is height, and then comma your Y variable, which is weight, hit enter, right? But remember, it doesn't matter if we switch the variables around, right? So if I do the opposite, we still get the same correlation coefficient, right? Which is what we talked about. So R is the same either way, right? All right, so that's how you do that in R. So again, if I wanted to calculate R first, I would want to look at a scatter plot. Does my scatter plot look to have any type of linear correlation? And then you can find that linear correlation, right, using R. All right, so real quick, I'll show you how to do this on the graphing calculator. All right, so let me X out of this, right? I had some things open from last time. So if I go into, I'm going to go to second and memory. I'm just going to clear all my lists, right? So option 4, right? So now if I go into stat, the stat menu, which is here, I'm going to go into edit, right? And this is where I can enter my data. So L1, I'm going to let be the height, the X, right? So I can just type this in 61, 62, 63. Let me pull the slide over here so it's side by side, right? So that's where I'm getting my data from, right? 63, 64, 66, then we have 68, right? Good. And then L2, we put in the weight, the Y, 104, 110, 141, 125, 170, and then 160. Right, so I have all the data put in, right? I'll just put this slide up just as a reference, right? So what we did is we entered my data, and then I'm gonna go to second quit just to go back to the main screen, and then we hit stat, and then go over to the calc menu, and we're doing option 4, right? So if I hit option 4, now it's telling me what list to use. So I have L1 for X and L2 for the Y, so I can just go down to calculate. And something to keep in mind is that this tells you to put L1 and L2 afterwards, but I'm wondering if this was a different version of the TI. So if you don't have a menu popping up like this, then you might have to do that. But here with my version, it's asking you what's the X and the Y, so we don't have to type it in. So if I just hit calculate, I'll get those, right? So you may or may not have to do like step 3, right? Right, so there's my line of best fit. Let's see, but it's not showing my R value. Let me check something out. Oh, I see, because I actually hit option 4, right? We want option 8. Right, so notice how they are a little different, right? So if I hit this, go to calculate. I'm still not getting my linear coefficient. So I believe this works on my standard graphing calculator. Let me double check. Alright, so I figured out why this isn't working. There's a setting in your calculator that you have to turn on first to get that. So I'm going to show you how to do that. You only have to do this one time, and it'll always be on there for you, right? So I'm going to second quit and just have a clear screen. Now if you hit second and the number 0, this will bring up your catalog. So this is all the commands in your calculator, right? And you want to scroll all the way down till you get to diagnostic, so in the D's. Right, so here, this is what we want, where it says diagnostic on, right? So my cursor is right beside that. I'm going to hit enter, and that pops up. I hit enter again, and now it says done, so it turned it on, right? So now when I go into here and go to stat, and then go to calc, and then do option 8, and then go down to calculate, hit enter, right there. So there's my R value, right? So we want to use just R, not R squared. We're going to talk about R squared in a moment, right? in the coming lessons. So just focus on R right now, the correlation of coefficient, and our R value is 0.8809, right? And if we remember right, that should match what R had, right? So R had, so 0.8009336, right? So it matches exactly, right? So that's how you can find the R using graphing calculator or using R, the program R. All right, so that's all I have for this section.